Hello and welcome back to another episode of Tech Made Simple. Big news today coming from the press release of RFID chip manufacturer Impinj, as they are looking to release their latest chip offerings inside their newest family of chips, the M700 series. A little over a year ago, they launched this new family of chips, the M700 series, starting with the M730 and the M750, which brought the RFID chip industry up a notch in terms of performance and sensitivity. Chip technology plays a pivotal role in shaping the RFID industry because chips literally are the heart of the RFID products out in the world. But no more talking about that. Let's jump into the latest chips coming from Impinj, and they are the Impinj M780 and M781. I went over some of the core reasons why chip manufacturers are looking to shift to this next iteration of chips in the RFID industry in my last video, which I'll link somewhere up above. If you want to see me break down kind of the precursor before the launch of this latest chip from Impinj, it had a lot to do with memory and some other things, so make sure you check out that video as well. All right, so M780, M781, what's so good about them? Well, first, they were designed to help enterprises in the medical industry, the food industry, and industrial manufacturing type industries, with the goal to manage product shelf life, reduce waste, and comply with some of the latest regulations coming from standards organizations like GS1. As if two new chips wasn't exciting enough, Impinj also announced some information about some reference antenna designs that are going to be out in public for inlay manufacturers and Impinj partners known as Core 3D. These antenna reference designs were made to allow for omnidirectional reading of inlays utilizing the M700 series chips. So again, for those new listeners, omnidirectional reading means that the RFID tag or inlay that is being read from the reader can be read regardless of the orientation of the RFID inlay. There are certain RFID antennas that are linear polarized, meaning they only read on one specific plane based on the setup of the reader. So an omnidirectional RFID tag can be read regardless of what orientation the tag is placed in. Another way to go about that is to use a circular polarized antenna. But again, there's so many trade-offs for that, and that's a different conversation, so I'll save that for a different video, or check out again some of my other videos covering those topics. All right, so focusing first on the M780 chip. This brings to the table a whopping 496 bits of EPC memory, which is a huge step up from the first iteration 700 series chips that offered a 96-bit and a 128-bit. So if you're looking at actual characters or numbers that you can encode into your RFID chip, that 496-bit EPC memory bank allows for 124 characters to be encoded into the RFID tag. That is a huge step up compared to, again, those predecessor chips which allowed only 24 characters and 32 characters. The second memory boost in this chip is the user memory bank also has 128 bits of memory, which again is a pretty big step up in terms of overall memory on board of this M780. Stepping over to the M781, we almost have an inverse memory setup when compared to the 780 because this tag has 128 bits on board for the EPC memory and has 512 bits in the user memory. I know the question is going to be asked, well, what's better, having more memory in the user or more memory in the EPC? This question is entirely up to your specific application and how your readers are set up to capture the data from the tags. Some people use the EPC memory bank to capture specific, say, product information or maybe just a specific unique serial information, whereas the user memory can be used to store other information like expiration dates, product manufacture dates. So there's different memory banks that can be used for specific reasons. So depending on the way your tag is set up, you may benefit from the 780 that has more EPC memory, and vice versa if you're tailored heavy towards a larger user memory bank, then you may benefit from the M781. So I mentioned expiration dates and information that you could store in, say, the user memory bank. And that's exactly what Impinj was going for with the design of these new M series chips. They wanted to focus this extra memory on batching and lot information, as well as, again, as production dates, expiration dates, or even weight of the overall item being tagged. Why Impinj decided to go this route? We need to take a look again at the way the standards are going in the industry. For instance, one of the big pushes for standards is, again, in the Walmart RFID mandate. How are tags going to be uniquely recognized coming from multiple different suppliers, multiple different vendors? How are we going to encode data that uniquely identifies all of these varying items coming into the Walmart stores? So GS1's EPC Tag Data Standard 2.0 is the latest standard available, which encapsulates a variety of different numbering systems to help clear up some of the confusion around tag encoding. So the extra memory and the new tag data standard from GS1 combined really allows supply chain partners to easily pinpoint products at a specific batch, lot, or even to recall products that may have hit an expiration date that otherwise would have gone missed. Another benefit is also that it allows some of maybe the older products to get shipped before some of the newer products. And that extra memory allows for that visibility throughout the life of the products. So now I want to hit on some of the highlights or the main product features of these new chips from Impinj. Many of these features that I'm going to highlight today are also available on some of the previous iterations of the M700 series chips, but again, it's good to highlight some of the main benefits of this newer chip technology coming from Impinj. The first feature is the enhanced Autotune with adaptive tuning. It sounds extremely fancy, and ultimately it really is a nice feature built into the chip. I've talked about on the channel how different materials and different substrates actually affect the tuning and performance of an RFID inlay. This feature on the chip actually recognizes when the tag is placed on a substrate. It's able to understand the tuning mismatch, which allows it to make a slight internal modification to transmit the best possible response in that specific application. This isn't a fix-all feature to where you can throw one inlay on any surface and it's gonna just read peak performance. No, that's not the case. But having that little internal feature that can optimize the frequency output is pretty helpful and is worth taking a look at. The next feature is the Impinj Integra Data Diagnostics. Coming straight from the name Integra, this feature actually does test the integrity of the chip in a variety of ways. It's testing for the health of the chip and validates the data encoding of the chip to ensure that, one, it was encoded with enough power so that the data won't be susceptible to corruption over time. The Data Integra also includes an error detection capability with the use of parity checking so that it knows if there is some sort of error that happens to one of the bits internally in the chip, there's going to be a flag that's flipped internally on the chip so that the user can understand that, hey, something went wrong with the data inside, whether it was because of poor encoding or some sort of fracturing to the chip or even to the bond connection overall. The M700 series chips offer what's called the Impinj protection mode, and this essentially just offers the consumer the privacy on their chips so that they can control who, where, and when the chips are being read. It essentially makes the chips and tags invisible to other readers that they don't want reading their specific tags. It's a powerful feature, and again, I highly suggest you look into it if you have privacy concerns in your RFID application. Lastly, a feature that I think is really cool and maybe even underutilized is the Impinj Unkillable Mode. It sounds maybe a little gory, but for my newer viewers, there is a feature built into all RFID chips, and that is the kill password. And this is a function that can be triggered, which will actually kill the tag, or which essentially makes the tag shut off permanently and will never turn back on. The unkillable feature on the Impinj 700 series chips is a feature that protects the chip from accidentally being killed when the intent is actually to use the protection mode. Killing a tag obviously prevents the tag from being read by any reader whatsoever. The protected mode ensures that it's only read by the readers designated by the consumer. All right, that just about wraps up today's video. I hope you enjoyed this product preview coming right from the press release of Impinj on their latest chip iteration in their M700 series family. If you like today's comment, make sure you leave a comment below, hit the like button, and if you haven't already, make sure you subscribe to my channel if you want to continue being up to date on the latest RFID news and technology. All right, with that, make sure you leave some comments below on what other RFID concepts you want made simple.